Hello everyone. The title of this video is Divide Complex Numbers. And in this video, I'm going to be going over several exercises. Each of these exercises is taken directly from a free online textbook at openstax.org, and it's their Intermediate Algebra 2nd edition text, section 8.8, titled, Use the Complex Number System. I'll be working under the heading Divide Complex Numbers. And I'm only going to be doing the even numbered exercises, so 458, 460, 462, all the way to 468. Right, you may notice that the odd numbered exercises have links on them, so you can click on these and it'll take you to the solutions. So I'm going to do the ones that don't have solutions. Additionally, I will also put timestamps for these exercises, for these examples, in the description of the video. So example 1's timestamp will be number 458, example 2's will be number 460, and so on. So you can move around to, different problems that you want to see ahead of time. And my final request of you is that when I bring up a new problem in the video, pause it and try to work on it yourself first before watching me doing it, and then compare. Because if you're just watching me do these questions and not practicing yourself, chances are you're not learning all that much. Okay, so the first question is number 458, and I have these written out. So you see example 1, exercise 458. Alright, so we're asked to divide some complex numbers. And what I'm eventually going to end up doing here, I eventually want to write every single result in what's called, the standard form of a complex number. So hopefully you recall from previous videos, if you've been following or watching my videos, that this is the form a plus bi, where a and b are real numbers and I, remember, I is the square root, the principal square root of -1. Right, I, pardon me, I is that imaginary unit, right, the square root of -1. So don't forget that I squared then is -1, right? I is a number that you can square and actually get a negative result. So I'm going to write all my results in this form, a real number plus an imaginary number. And in order to do that, it's going to be just like rationalizing a denominator with a square root in it. Remember that if you remember that I is the square root of -1, what we have in the denominator of a lot of these problems is a two-term denominator with a radical, with a square root. And you may recall that to rationalize such a denominator, we multiply by the conjugate. So something else I'm hoping you recall from previous lessons, previous videos, is that when you multiply conjugates, right, take a plus b, multiply it by its conjugate, a minus b, you end up with a difference of squares, a squared minus b squared. Right? Or, if you're talking about complex numbers, if I write a number in complex standard form, a plus bi, and multiply it by its conjugate, a minus bi, still results in a difference of squares, right? It's a squared minus bi squared, but bi squared, right, is b squared I squared. And don't forget, whenever you see I squared, that's negative 1. So this minus b squared times I squared becomes minus b squared times negative 1, which should be positive b squared, a squared plus b squared. And notice that this final result, when you multiply two complex conjugates, the final result is strictly a real number, right? There's no I anymore, right? It's just a squared plus b squared. No more I, no more imaginary unit. So that's going to be very useful for us in the division by a complex number. Right, so a bunch of stuff to remember from earlier. So in number 1, we have 5 minus 2i divided by 2 plus 5i. The key is to, I'm going to multiply the numerator and denominator by the same thing. And since each of these have two terms, I'm going to put parentheses around them. And what I'm going to do is I'm going to multiply the numerator and denominator by the conjugate of the denominator. Alright, so that would be 2 minus 5i, right? 2 plus 5i. The conjugate would be 2 minus 5i. Alright, and I do the same to the numerator. Right? Multiply. You can't multiply the denominator by something and not the numerator, right? You got to make sure you're multiplying by something that's equivalent to 1. Right? But I'm multiplying both the numerator and denominator by 2 minus 5i. Right. Now the numerator, I did a video before this on multiplying complex numbers. You just do a lot of distributing, right? So distribute the 5. I'll just draw one arrow. So 5 times 2 is 10. And 5 times negative 5i would be negative 25i. And then I'm done with the 5, and then I move over to the negative 2i and distribute that. Negative 2i times 2 is negative 4i. And negative 2i times negative 5i would be positive 10i squared. But remember, 10i squared is really negative 10, right? Because I squared is negative 1. So the numerator, when all is said and done, is 10 plus negative 10 is 0. And then we have negative 25i minus 4i, making negative 29i. Right, negative 29i. Alright, so that's the numerator. And the denominator, I'm going to just use this little formula I wrote over here. When we take a plus bi and multiply it by a minus bi, right, multiply two complex conjugates, we end up with just a squared plus b squared. So 2 plus 5i times 2 minus 5i, we'd end up with 2 squared plus 5 squared. I'll write that here, 2 squared plus 5 squared in the bottom. Something that's just totally real, no imaginary. And that's 4 plus 25. 4 plus 25 is 29. And then we simplify, right? Right? Divide every term, there's only one term in the numerator. Divide every term in the numerator by this denominator. Well, if I divide by 29, hopefully you can see the 29s would cancel, and I'd be left with negative I, right? Negative 1I. Or 0 minus I, right? If you wrote it in standard form with the real number being 0. 0 minus I. But, usually a term of 0 is not written because it doesn't mean any, it doesn't add anything, it doesn't change anything. So just minus I, or negative 1 times I, is the result of dividing 5 minus 2I by 2 plus 5I. Great. Now, I'm going to check this with a calculator. You saw me do this in the last video on multiplying complex numbers. I have a TI-84 Plus emulator that I'm going to be using. Let me pull that up here. And you may notice that up top on the screen, the calculation screen, it says, normal, float, auto, and then it says A plus BI. So if you hit the mode button, you can change it from real mode to this complex mode, A plus BI. And now when you punch in the square roots of negative numbers or whatever, it won't come back with an error. It'll actually give you, the complex number in standard form. It gives it in this form, this A plus BI form. Alright, so I'm going to enter the initial expression we were given. Right, so I'm in parentheses, because the numerator and denominator have multiple terms, I'm going to put them in parentheses. Numerator was 5 minus 2I, right, and the I is above the decimal point, and I have to hit second here. So there's 5 minus 2I divided by, and then in parentheses, 2 plus 5I. Alright, so this is what we were initially given, and I'm hoping that the final result, in standard form is just minus I, or 0 minus I, right? They might actually come back with 0 minus I, let's see. Just minus I. See, usually a term of 0 is not written, because it doesn't change anything. Wonderful, and that's exactly what I got doing it by hand here. Alright, so 5 minus 2I divided by 2 plus 5I is indeed 0 minus I, or just negative I, negative 1I. Fantastic. Alright, and I'm only going to use this calculator to check the first two questions, just this first page here, and I'll leave the rest to you. Okay, great. Next question. Alright, so number 2 is exercise 460 in the text. Same thing, we're dividing complex numbers. 3 minus 2I divided by 6 plus I. And just like in example 1, we're going to do this in every example. I'm going to multiply the numerator and the denominator by the same thing. And what I'm going to multiply by is the conjugate of the denominator. 6 plus I has a conjugate of 6 minus I. Right. And the same for the numerator, right? Multiply it by 6 minus I, right? You can't multiply the denominator by something and not the numerator. We want to keep the expression equivalent. Alright, wonderful. The numerator, when I multiply this out, right, first I'll distribute the 3, get 18 minus 3I, and then I distribute the negative 2I, get minus 12I, plus 2I squared. But remember, this is just minus 2, so we have 18 minus 2 is 16, and then minus 15I. Okay. Wonderful. Alright, so there's the numerator in standard form, 16 minus 15I. and the denominator should just be a real number. All right, when I multiply two conjugates, 6 plus 1i times 6 minus 1i, if you remember the little formula over here, this ends up being 6 squared plus 1 squared. Right. And you can check it by foiling and all that. You end up with 36 plus 1, which is 37. Right, so the denominator is 37. And this is great. I mean, you can circle this if you wish, but as I said in the beginning, I want to put all my final results in this standard form where I have a real number term and then imaginary number term. So that's simple enough. But I just divide every term in the numerator by 37. So this is 16/37ths. Right, there's the real number term. And then minus 15/37ths times I. Right, there's the imaginary number term. And these fractions, 16/37ths and 15/37ths, those do not simplify any further. So I'm done. Right, this is the final result of dividing 3 minus 2i by 6 plus I. And again, let's check this. Right, so I'm going to pull up my calculator and we'll enter and make sure I'm in that a plus bi mode, not real mode. And the numerator was 3 minus 2i divided by the denominator was 6 plus I. And we're going to get some crazy decimals here, right? 0.432432, etc. minus 0.405405405i, right? So my hope is that this number, right, the real number, is 16/37ths, which is what I've written here. And my other hope is that this number times I, this number is 15/37ths. Well, since these are fractions, you can actually have your calculator here change things to fractions if they are actually fractions, actually rational. I hit the math button and then just hit change to fraction, and it changes the previous answer to a fraction, all the fraction parts. Wonderful. And that's exactly what I had, right? 16/37ths minus 15/37ths times I. Exactly what I wrote out by hand. Wonderful. Okay, so we did well. Alright, so let's keep this in mind. Again, when you multiply conjugates, a plus bi, a minus bi, you end up with a real number, a squared plus b squared. Keep that in mind for the rest of the video. Alright, so the next example, number 3, exercise 462 from the text. I have 2 divided by, or 2 plus 0i if you want to write it as a complex number. But no need to write plus 0i. Usually terms of 0 are not written. We have 2 divided by 4 minus 5i. And once again, I am going to multiply the numerator and denominator by the conjugate of the denominator, which would be 4 plus 5i. Right, 4 plus 5i. And the same in the numerator. Alright, so the numerator is simple, and it's only one thing to distribute. Alright, just distributing that 2. 2 times 4 plus 5i would be 8 plus 10i. And then the denominator, 4 minus 5i times 4 plus 5i. I'm multiplying complex conjugates. This will end up being 4 squared plus 5 squared. All right. So we have 8 plus 10i divided by, this is 16 plus 25 here, which is 41. 41. And as I said with example 2, this is fine. The denominator is rationalized, but once again, I would like to put it in that standard form for a complex number, right? A real number term plus some imaginary number term. So I'm going to go and divide each term in the numerator by 41. Right, so we end up with 8 divided by 41, right? 8 41sts. There's your real number term, plus, and then 10 41sts times I. And that's it. And 8 41sts and 10 41sts, those do not simplify any further. You should, again, simplify your fractions if possible. And once again, I leave it to you to check, with a calculator if you want, but 2 divided by 4 minus 5i is, 8 41sts plus 10 41sts I. Wonderful. All right, next question. All right, number 4, example 4 here is exercise 464 from the text. Same thing, just dividing complex numbers, -1 plus 0i if you want to write it, divided by 3 plus 2i. And one more, yet again, I'm doing it with all of these. Multiplying the numerator and denominator by the conjugate of the denominator, which would be 3 minus 2i. Alright, 3 minus 2i. Alright, so distributing the -1, the numerator becomes, -3 plus 2i. Alright, and the denominator, once again, we're multiplying these conjugates, 3 plus 2i, 3 minus 2i. We would end up with whatever 3 squared plus 2 squared is. Now that's 9 plus 4, which is 13. So we have -3 plus 2i in the numerator, and then just 13 in the denominator. And again, this is fine. The denominator is rationalized, so most people will take this if you circle it. But once again, I'm trying to write it in the standard form here, so let's get a real number and an imaginary number added together. Divide each term in the numerator by 13. So for our real number term, we have -3 13ths. And for the imaginary number term, we have plus 2 13ths, times I. Wonderful. And these fractions do not simplify any further, so I'm done. Alright, once again, I leave it to you to check, is -1 divided by 3 plus 2i equal to this? Now, another way to check would also, I haven't mentioned this yet, but another way to check would be to, multiply 3 plus 2i by -3 13ths plus 2 13ths I and see if you get -1. Alright, take the denominator, right, the divisor, multiply by the quotient, and see if you get the dividend, right, fancy words for division. That's another way to check as well. And it should work out. I leave it to you, though. Okay, next question. Alright, so now we have, example 5. This is exercise 466 from the text. We have 4 plus 3i divided by 7i. Now, if you want, just for the conjugate purposes, I can write this in standard form, right? This would be 0 plus 7i, right? If I write it in standard form for a complex number where the real number part is just 0, and we get 7i. And then I'm doing the same stuff as always. Multiplying the denominator and the numerator by the conjugate of the denominator. Now this is a little simple here because the conjugate of the denominator would be 0 minus 7i, 0 minus 7i, or just minus 7i. Alright, so I'm going to multiply the numerator and denominator by negative 7i, right, and ignoring the 0. Alright, so up top, we just need to distribute the negative 7i to the 4 plus 3i. So that gives me, negative 28i, and then minus 21i squared. But don't forget, I squared is negative 1. So this second term here becomes positive 21, and I'm going to put that first. I like putting the real numbers first, right? Positive 21, and then you have minus 28i. All right, so there's the numerator. And the denominator is going to be 0 squared plus 7 squared. So just 7 squared, right? Or 49. Right? Okay. So again, 0 squared plus 7 squared, but it's just going to be 7 squared. Or you could say negative 49i squared, but I squared is negative 1, so it's positive 7 squared, positive 49. All right, then once again, I'm going to just divide each term in the numerator by 49 here. So we have 21 49ths for the real term, and then the imaginary term, minus 28 49ths times I. Right? But these fractions here are not simplified. We should simplify fractions. Now these have a common factor of 7. This is 3/7, right? 21 49ths is 3/7, dividing the numerator and denominator by 7. Minus, and then 28 49ths. Those both have a common factor of 7 as well. Divide out by 7, you got 4/7 times I. All right, so 3/7 minus 4/7 I is the final result here. And once again, if you wish to check, take 4 plus 3i, divided by 7i, what we were originally given, and see if you get this, or multiply the result by the denominator, take 3/7 minus 4/7i and multiply by 7i, distribute 7i, and you should simplify to be 4 plus 3i, right? And get the numerator back. But again, I leave it to you to check. Final question. All right, example 6. This is the last one in the video. Number 468 in the text. Same thing. All right, we got negative 3 minus 5i divided by 2i. Now I'm not going to write it this time, but we can think of 2i as 0 plus 2i. All right, think of it as 0 plus 2i. So I'm going to, when I multiply the numerator and denominator by the conjugate of the denominator, that conjugate is very simply 0 minus 2i. Right, so negative 2i, just multiplying the numerator and denominator by negative 2i. All right, in the numerator, I'm distributing the negative 2i to this negative 3 minus 5i. That'll be 6i. And then plus 10i squared. But remember, I squared is negative 1. So this term is actually negative 10, and I'm going to put that first since it's the real number term. Negative 10 plus 6i in the numerator, and the denominator would just be 2 squared. Right? 0 squared plus 2 squared, or 4. Okay. And yeah, because this would end up being negative 4i squared, but negative 4 times negative 1, right, is positive 4, so you should have positive 4 in the denominator. All right, and then like with all the others, I'm writing it in standard form. Divide each term in the numerator by this real number 4. we'd have negative 10/4 for the real term plus 6/4 times I for the imaginary term. But, these fractions can simplify. 10/4, negative 10/4 would reduce to negative 5/2 or negative 2.5 if you want to write decimals. Plus, and then 6/4 reduces to 3/2 or 1.5 if you want to write a decimal, times I, right? So negative 5/2 for the real term plus 3/2 times I for the imaginary term. Fantastic. And then once again, if you wish to check, you could use a calculator or multiply the denominator by your result, by the quotient, and see if you get the numerator back, right? See if you get the dividend. Wonderful. Alright, so yeah, every single one of these I did the same thing, right? Dividing these complex numbers, you're multiplying the numerator and denominator by the conjugate of the denominator, right? And when you multiply two conjugates, you should end up with just a real number, right? No I. Wonderful. Alright, so I'm hoping that watching me go through these 6 questions here, these 6 examples, help you in some way when you're asked to divide complex numbers yourself. And thank you very much for watching.